The paper I present today is a joint paper with Sabrina Bravaccini and Dimitri, who just talked. And Sabrina was actually a master student. She has now returned to non-academic life because Sabrina is actually an athlete. She's a swimmer. And thanks to her help, we could organize this experiment. And I think the most difficult part in this project was to access to athletes to convince them to participate in the experiment. We tried several times, Dimitri and I, because this project, we had this project for a long time. And the real difficulty was to approach the athletes because they were never, they had never the time to come to the lab and do the experiment and so on. So that was very important to have Sabrina involved because she's an athlete. And she convinced many athletes to participate, and so we could have quite a large sample of people involved, thanks to her involvement in this project. So, two objectives for this project. The first one was study athletes' preferences based on simple games that you probably all know. I just recall them later. And also highlighting the gender gaps, comparing athletes to non-athletes with respect to two gender gaps. The first one is about competition. So you're probably familiar with the Niederle-Westerlund task that I will explain later. And also another gender gap that is quite well known is about risk-taking. So we studied both these two gender gaps in an athlete sample and a non-athlete sample, and you will see there are some interesting differences because these gaps are much lower in the athlete population. So two questions that motivate this research. Why studying athletes who practice competition? Why is it interesting to target this kind of subjects? And the second and the most important question, actually, this came out later. Actually, we wanted first to study just preferences, and then it came out that there was a difference in the gender gap, in particular in the gender gap in competition between athletes and non-athletes. And so we have this interesting question: why could there be a lower gender gap for competitive athletes? So, why studying athletes who practice competition? Maybe a very basic reason is that sport practice involves competition in most of the cases. Athletes are more likely, therefore, to behave as homo economicus, as we like, as economists, to have this nice behavior that we teach to our students, which means self-centered rational agent. So competing with others can develop this kind of homo economicus aspect of the personality. Also because it develops some beneficial effects on pride, self-esteem, and self-confidence, which are often mentioned in the psychological literature, in addition to rigor, discipline, confidence, and motivation. But maybe much more is context is likely to reinforce some specific behavioral trait, which I qualify as competitiveness and risk-taking. So competitiveness, we're going to see how we measure it. But one easy way to do is to just replicate the Niederle-Westerlund task. And risk-taking, there are many measures that I will present later. So these traits are likely to have a particularly strong expression in athletic sports, which probably develops other kinds of traits like maybe coordination or cooperativeness or some other aspects. So I have no feedback for the moment on team sports, but we only focus on individual sports, and we will give some examples later. And also the strength of this trait may depend on the type of individual sports. For example, if you do compare swimming to combat, so that's very different because both are not exactly in the same configuration. So some trait might be stronger in some type of activity than the other. The length of time also of the sport, for example, marathon running or 100-meter running, is probably develops different skills, different aspects. whether there is direct or indirect aggression. For example, boxing versus tennis. So tennis, there is also, it's a combat between two persons, but probably there is less involvement in the tennis and then boxing. And of course, there are many other possible characteristics. So our hypothesis was, despite this very large heterogeneity in individual sports, there is some common view that we qualify as competitive spirit. Okay, and there is actually a very large literature also. This is another part of the motivation in social science, like psychology and sociology, about sports and sport behavior. But there is not much in economics. There are a few papers, less than 10, I would say, that really address this issue about preference in athletes. There is, of course, a very large literature in sports economics, but very few papers actually address this issue about behavioral patterns or behavioral traits of athletes compared to non-athletes. Why should sport practice close the gender gap in competition? So just to recall, what is the gender gap? According to economists, we have now this nice measure that was provided by Netherlands and Westerland, incentivized the way to identify competitiveness with respect to many dimensions. Gender is just one, but the most important probably. So the first paper was published by Netherlands and Westerland in 2007. And there was a survey paper by Netherlands in 2015, which collects a lot of replication. So this is a very now large evidence that women are less likely to select into tournament when given a choice between a piece rate payment and a tournament payment. So actually this choice was first experimented by Niels and Westerland's task. So the task was very simple. It was adding up 5 two-digit numbers time. And actually, there were three consecutive treatments. So subjects first were paid according to piece rate. So how many correct answer they could make in a 50 minutes time. Then in the second round, they had a tournament payment, which means they were matched with other people, exactly 3 other people. And the highest score was the winner, was decided to be the winner. And the lower scores had 0, okay? So the payment was $2 for the winner of the 4 and 0 for the loser. So that's if you have a 25% chance, say randomly, to be the winner, so you get the expected value of your payment is the same as in the piece rate. Another way to interpret this $2 is to say it's just a winner takes all. So you get 50 cents for all 4 persons instead of sharing the 50 cents between the 4 persons. So that's another way of looking at this $2. Okay, it's just adding up 4 times 50 cents for each correct answer. This is a nice measure, but it's a binary measure actually, because you can only categorize people into competitive or not competitive according to their choice. I forgot to say that in the last round, actually people had always the same task, but then they were asked, would you like to be paid piece rate or would you like to be paid tournament? Knowing that in the previous rounds, they already experienced each one. They experienced the piece rate payment, they experienced the tournament payment, and they got feedback about that. Private feedback, of course, not public feedback. They only knew their payment. And then in the last round, the third round, they had to choose between. So that's the way the gender gap has been shown. And the main result is that, if I remember correctly, I think that 2/3 of the men chose the tournament, and only 1/3 of the women chose the tournament. So there is a huge gap. It's twice as much. So other measures can be thought of to complete this binary measure, especially in psychology literature. There are other measures of competitiveness. They have stated preferences or declarative methods to measure this. Related literature is important to mention is basically the labor economics literature that show that there is a wage premium, okay, which is in favor of former athletes. So former athletes earn on average between 5% and 20% more. The first paper was, these are all empirical papers, not experimental papers. There is a large literature that had going back to the seminal paper by Long and Codin in 1991, and which was replicated. The first one was in the US, and this was later replicated in the US and in other countries. The most recent one I found was Leschen and Downward. I think it was for European countries, and they found this, you have this large wage premium that can vary up to 20% between former athletes when they were at school or university, and former non-athletes, and there is this nice difference. Employability, so there is a definition here about employability, what it means exactly, but the result is that former athletes are more employable, which means they are more easily contacted when they send a CV for a job offer compared to their equivalent non-athletes. They are much more employable in this sense, okay? And in particular, because in this literature, what they show especially is that there are some soft skills besides the technical skills that you ask to an employee, a future employee, like computer or handling some software or whatever. There are also some soft skills which are not in the CV, like leadership, never give up, or combative, which are the likely trait that you're looking at in a competitive athlete, and that are very likely selected by many employers. And also there is some literature showing that when you talk to future employers, they put some value on this kind of soft skills, and especially there is higher employability of former athletes. Also, there is another literature. Yes?
Yeah, just someone asked whether it's true for men and women, boss?
Yeah, there is no, it's a bit stronger. Yeah, this is a good question. It's a bit stronger for men. I mean, the wage premium employability has been shown to be stronger for men. It does exist for women, but sometimes it's not significant. Yes, these properties are stronger in men than in women. Also, performance pay has been shown that former athletes are more likely to be paid on a performance-related basis when they become professionals after they finish their athlete life, so to say, or when they are no longer students. Most of the time, all these studies have been done with students, with former students that were performing during their studies. And finally, there is also literature showing that school performance and professional achievement is linked to sport participation, and especially to competitive sports. So this is a bit challenging view, because standard models of allocation of time predict lower achievement for people who practice sport because they spend less time studying and more time in sports. But if you take into account the allocation of leisure time, not only of time, working time or time as general, so actually people who practice sports spend less wasting time for the leisure. They waste less time because they spend their leisure time investing in sports. So it's a kind of human capital that is built up besides the human capital that is corresponds to their studies. So this is why. If you be careful about that, for example, Pfeiffer and Cornelissen showed that there is a strong impact of sport participation in childhood and adolescence on educational achievement. They have better success at bachelor, for example, or at baccalaureate or things like that, diploma like this. And finally, so if you look at the sport literature, you find many papers that show that the gender gaps that exist in sport records for a long time, for over 100 years or more, have been narrowing very much over the last 50 years. And the best example is marathon running. When you look at the top runners in male and female, the time difference is shrinking very fast over the last 50 years. And I think that, I don't know exactly the current record, but the difference between men and women is very small now currently. And this is also true for other sports. So the objective, as I said, was when we initiated the project, was to study the behavioral trait of athletes using incentivized economic experiment, because all the existing evidence was on psychological methods based on questionnaires. So we wanted to use incentivized experiments to contrast what finding with psychology literature. The second goal was to answer the question, to what extent does sports practice close the gender gap in competition? So there are several possible channels through which this gender gap might be closed. Individual preferences. So there is a higher propensity to take risk. For example, because most sports, especially individual sports, seek to know their rank. So they compete to increase their rank. So ranking feedback is very important for them. Preferences. So we find, this is I announced one of the results, is that we find that athletes are more selfish in the dictator game. They are less cooperative in a prisoner's dilemma game. And also there are some personality traits that has been shown, especially in the psychology literature. For example, Steka et al. Found recently that athletes who experience the most success in their sport have higher scores in each personality dimension of the big five, except openness. So they rank higher on this dimension. And Laborde and co-authors found that athletes not only score higher on the personality trait compared to non-athletes, but that individual sports athletes rank higher than team sport athletes. So within the category of athletes, it seems that individual sports leads to really sharp differences compared to non-athletes, and also differences compared to team athletes. So the experimental design, to answer this question, we have experimental design is constituted of 4 blocks. So we have a first block on we elicit risk preferences, second block on social preferences. Then we have the competitive task. We have actually 2 tasks. I will explain why we decided to have 2 competitive tasks, and some questionnaire which are self-declared and general questionnaire. So I will now give the details about each block quickly before the results. Portfolio choice task, we use 2 tasks, the Gnisi-Potter portfolio choice task. So you have to allocate this task 10 euro between the safe option, just keep the money, and the risky option, which is a 50% chance of winning 0 or 50% chance of winning the triple of the amount invested. So for example, if you invest 5, you will get 15 with 50% chance, and 0 is 50% chance. The second task, we use a very simple, probably one of the oldest tasks, besides the certainty equivalent method. It's the was introduced by Binswanger in 1980 in his PhD research. So it's a lottery choice task. It was simplified later on by Eckl and Grossman. And sometimes it's called the Eckl and Grossman method, but this is true. The inventor of this method is Binswanger. And basically, you have to choose a lottery. So sorry, this is in French. We didn't have time to translate it. And all lotteries are binary lotteries. You have 6 lotteries. The probability is the same for the 2 outcomes. So there is no issue of probability weighting here because it's always 50%. And so, for example, the first lottery, you are sure to get 28 euro if you choose this one. If you choose, then if you go down, you increase the riskiness of the lottery. For example, if you take lottery 4, you have a 50% chance of winning 16 or 50% chance of getting 52%. So the idea is very simple. When you go increase the number, you have higher expected value. of the lottery, but you also have a higher riskiness. For example, you take the measure, the variance of the lottery, it's increasing with the number. So the higher the number, the higher the riskiness, or the more risk-loving you exhibit in this task. Okay, you can also show that this each choice corresponds to some interval, for example, with the CRRA equivalent, constant relative risk aversion. So, but it's enough to just take the numbers. So it's a kind of ordering of riskiness. For the social preference block, we have several games. So we have a dictator game. This was used to measure selfishness or selfish orientation. Ultimatum game, which is a very standard trust game. So the trust game is here the investment game by Berg, Dicount, McCabe, 1996, 1995, sorry, and the prisoner's dilemma game. So for all these games, we use the strategy method. So people play both roles. So in the dictator game, everybody played the dictator. In the ultimatum, they played the first mover decision, and then as a second mover, they had to decide whether to accept or reject any of the proposed amounts, similar in the trust game. And we use a 10 euro endowment for the three games. For the DG, UG, and TG games, we have a 10 euro endowment that could be used by the subject. The prisoner's dilemma, I forgot to say that one game only was paid. We told them that they are going to play several games, and one will be picked up at random, including the individual, the risk preferences task, the two tasks I described before. One out of 7 games was paid only, and randomly selected. This is the prisoner's dilemma game. So it's also in French, sorry. So you see, you could win between 66 euro or 19 euro, depending on the combination. Okay. So that's for the incentive. And then we have 2 competitive tasks. Why did we choose to have 2 competitive tasks? This is because in the literature it has been shown that the nature of the task can matter. For example, this has been shown by Dreber et al., who compared several tasks, and selection into competition depends on the nature of the task. So we decided to have actually 2 tasks: a cognitive task, which is a counting task, like it's similar to what Netherlands Westland implemented, and the physical task, which was throwing balls in a basket. So maybe we thought that this physical task would be more likely chosen by athletes because they believe that they're better at physical tasks than at cognitive tasks. So we had both of them, and so we can compare the 2. So the cognitive task, the counting task is very simple. We ask people to count as many mattresses that they could. So counting means we have to count how many ones are in this picture. Okay, so you have to get the exact count. Once you have counted the number of ones, you enter in the small box on the screen, and you get immediately the answer if your counting is correct or incorrect, and you get some payment. For piece rate payment was 50 cents per correct count. So people had basically 5 minutes to count as many matrices as they could. Okay, so the more you count correctly, the higher you get piece rate. The tournament payment was 2 euro for the winner of the tournament. So people were paired, not paired, sorry. There was in groups of 4 for this task, and the loser, the winner was the highest score, okay, the higher correct counting, and all 3 others were losing. So the 0 euro for the losers. The second task was a physical task. So I tried to make a picture to make it simple to understand. So people had 3 balls, and they had to throw these balls in a basket like this one. So it's the same shape, and they were 3 meters apart. So there was a kind of sign on the par terre. I don't know how to translate this. Okay, and they had to throw the balls into the basket. So very easy task that everybody can do easily. There was no special advantage for athletes for doing this, because these balls were kind of soft balls, so it's not a usual game that you play every day. Okay. So again, the incentive for piece rate was €1 per ball in the basket if you choose a piece rate. If you choose a tournament, people were paired in this case, so they were paired with an unknown partner, and each difference in score. So, for example, if you have a 1 point difference with the other person, you get €3 for point difference. So this could be from 0 to 3. Okay. So it can be 4 points difference. Okay, so that's for the incentive. And this is similar. So we are not the first one to use this kind of physical task to use to play the tournament versus piece rate task. So they, for example, Nisi and Anderson and Cotters also use this similar type of task. Finally, last block was questionnaires. So we used a self-declared risk attitude by domain and quotas from a 0 to 1, 10 scale, 0 to 10. You have to state if you are somebody who likes to take risk or dislike between 0 and 10 risk. So it's a stated preference risk attitude. And this is also then the same question is asked for different domains like sports, finance, driving, health, and work. So they actually answer 6 times the same question. And then we had a short demographic questionnaire just for having some control variables like gender, year of birth, studies, and so on. We also had a question about masculinity, femininity questionnaire. So it's the BEM sex role inventory, because sometimes it is not so much the biological gender that matters, but it's the sex role that really matters. It means you are more feminine or more masculine, and this can be is somehow independent of the biological factor. So we want to control for this masculinity, femininity trait in our subjects, and this questionnaire actually has I think 60 items questionnaire. 20 of them are linked to masculinity, 20 of them to femininity, and 20 are neutral. So you can compute the score, masculinity score, by taking the 20 masculine items, or the 20 feminine items for the femininity score, and the others you don't use actually. And you get for each item, people adjust to rate themselves between 1 and 6. Okay, so for example, you are aggressive, so you answer between 1 and 6. Okay, and then some final questionnaire about their sport activity, which we already had some data before because we selected the different participants. Okay, so I'm almost done with the design part. So we use a complementary measure to tournament selection. So we have a second measure of competitiveness. So one measure is the tournament selection. If you select the tournament in the 2 tasks, competitive task means that you are competitive versus non-competitive. Okay, and we use a complementary measure that we actually base on some of the items of the BEM sex role inventory. So we use 4 items. 3 of them are taken from the BSRI, which are masculinity items. So one of these items is athletic, competitive, and ambitious. So we took these 3. And we have also an independent item that was taken from a subsidiary questionnaire, which is I like to win, you like to win or not. So we take all 4 and we compute the average simply. So each item is measured from a scale from 1 to 6. Okay. So for example, if you are very athletic, you put 6. If you're not at all athletic, you put 1. And the same for the others. So first observation is that the average TI, competitive index, is 5 for athletes altogether and 3.88 for non-athletes. So you see, you start seeing a difference between the two. Okay, the athletes see them as more competitive as non-athletes, and you see the same by gender. For the female athletes, it's almost 5, 4.96 versus 3.69 for female non-athletes, and for male you have a similar difference. Okay, it's almost the interval is a bit smaller. No, it's almost the same. It's 5.03 versus 4.10, and you see immediately why we are interested in this question of closing the gender gap. You see that female athletes are more competitive than male non-athletes. So competitiveness seems related to the practice of sports, of competitive sports. We cannot guarantee for at this point if there is a causality issue, because we cannot know why this person, our subject selected into competition or not. I mean, in real life, why are they athletes or non-athletes? So we cannot, we can only make correlations for at this point. The participants. So with the experiment was run at the LISER experimental laboratory in Luxembourg University in 2019. Non-athletes were simply recruited on the local subject pool, which was all seated at base, like in most of our laboratories. For the athletes, it was most complicated. This is what I said at the beginning. This was really a challenge to recruit athletes. The reason is that these people practice all the time because they want to win the competition. So they practice all the time. They don't have time to do something else. Most of them are students. Almost all of our participants are students. We have a few non-students. So the athletes go study at university, and when they have free time, they practice and they train. So when you ask them to go to a party or whatever, they have no time for that. So this was a really challenging issue to get them to the lab, to bring them to the lab. And this was done with 3-level recruitment. So first, Sabrina sent some emails to the Sports Federation of Luxembourg, informing about the general purpose of our research, why we do that, and so on. Then the federations forwarded this email to sports clubs that were affiliated to the general federation. And the clubs informed their athletes. Not all did, but most of them did inform their athletes about the opportunity to participate in this experiment and ask them to contact the experimenter to enroll in the experimenter, because they were not on the ORC database, of course, so we had to include them. And so they got a message for inviting them to participate in the session. Okay. So our sample, we have 77. So we have a total of 168 participants. 77 are categorized as athletes. So they practice individual sports and they participate regularly in competition. And they are all in a sports club, of course. This is the way we. 78 are categorized as non-athletes. They do not practice any sports. So that's 70 of them. Or they practice sports as an amateur without competing. So that's 8 of them. We have a few. We had a few people that had to be that needed to be skipped because there was some people. We asked them. We first asked them only. We recruit only individual sports participants, but some of them were in team competition. So 12 of them actually declared participating in competition in teams, team sports. So sometimes it's also because when you do individual practice, you also do team practice. For example, running in a group or running individually. So you make both. In some sports, you make team as well as individual. So we skip them because this was not our target. And there was also a chess player that is doing a lot of that's doing chess contests. So if he see himself as a individual sports competitor, but we decided to discard this data. but it does not change very much our conclusion if we include it or not. Okay, so that's about, so finally we have a sample of now 155 after deletion of these 13 data points. We have 155 observations. So preliminary results, are there some difference between the athlete sample and non-athlete sample? So obviously there are some differences, you see them here. We have four demographics, age, student, and study level. So there is no difference in student study level. So these are percentages. For example, students, we have 45%, 46% of the athletes are students, so for 83% for the non-athletes. But you see that obviously for male and age, we have a difference. 66% of the athletes are male. So we had, it's not gender balanced, okay, for athletes. For the non-athletes, it's closer to 50%. So there is a difference that is significant. And also there is an age difference. So basically, the non-athletes are a bit older and there are more males in this sample. So we need to control. This means we need to control for these two variables in our analysis because this might affect the difference in competition. Now, if you look at the behavioral variables, so all the variables that were elicited, here two variables, so everything is converted here into percentage to make the more easy comparison between the different lines. So this is the first block, comparing risk taking. So in the Gnisi Potter task, investing, okay. This is the Binswanger task, the lottery choice, so it's called Bean. So you see there is no difference. Okay, athletes and non-athletes invest on average the same percentage in the portfolio choice task. They choose on average the same average lottery. Okay, there is no difference, but there is a difference in the dictator game. So athletes are more selfish; they give less, 34%, compared to non-athletes, 42%, more or less. For the ultimatum game, the rejection rate of the ultimatum game, so this is ultimatum sending, ultimatum rejection rate, the trust, the amount spent in the trust game, and reciprocity, average reciprocity, there is no difference between athletes and non-athletes, at least according to t-test. For cooperativeness, we find that athletes are less cooperative. They are more frequently choosing defect compared to non-athletes. And finally, we have our two tasks that measure competitiveness, the counting task, so counting the number of matrices, okay, and the ball throwing task. Okay, so we see here that obviously this is the frequency of tournament choice. So athletes choose more frequently the tournament than the piece rate for both of these tasks. So and this is also significant according to just t-test. Okay, so there are some behavioral differences that appear clearly in the first descriptive analysis. We have also in tournament selection. So here you have the two tasks that this note is wrong. I forgot to delete it. So what you see in red here are the percentages. So this in the ball task, for example, we see that 61% of the athletes choose the tournament compared to only 27% of the non-athletes. So that's a big difference. Okay. There is also the same difference in the same direction for the counting task. 57% of the athletes choose the tournament compared to 41% for the non-athletes. Okay, but the difference is obviously much weaker than in the ball task. So we have a difference in competitiveness that is visible through the tournament selection, like in the Niederle-Westerland task. This is stated risk preferences. So there are also some, there is no difference in behavior in the portfolio choice task and the lottery choice task. There is no difference, but there is a difference. See them as more risk seeking overall. Okay, so 66% compared to 55% for 54%. So that's the average note that they give on the scale from 0 to 10. So they see themselves as more risk-taking. They also see themselves as more risk-taking in sports, and that's all. So that's the two differences that are significant. For the other domains, there is no difference. And finally, we have a higher M score, masculinity score, for athletes compared to non-athletes, and also a higher competitive index. I already showed this before. So these are some descriptive results. Now, I'm going to state our main results. So we have 3 results that I want to discuss. First, athletes are more likely to select into competition. Second, there is a gender gap in competition, which is mitigated by competitive sport participation, which means that the gender gap is reduced for female athletes. Okay, and there is a slight gender gap in risk-taking, which is also mitigated by competitive sport participation, which means that female athletes are more risk-taking than female non-athletes. So this reduces the gender gap for these two dimensions. So the first result, selection into tournament. Athletes are more likely to choose a tournament payment in both competitive tasks. So we use for support, we use logic regressions, and we show the marginal effect at the mean. So we have here the variable athlete means it takes value 1 if it is an athlete and 0 otherwise. You see obviously that in these 5 regressions here, the dependent variable is tournament choice. Okay, probability to choose tournament. So athletes, you see there is a strong effect. Okay, so that's a marginal effect actually. So being an athlete increases by 35% the likelihood to choose tournament for the ball task. Okay, so that's one of the 2 tasks. So if we add controls to that, various control like the two demographic control, we needed to take into account. We observe also there is a gender effect on choosing tournament. Okay, and there is also a gender, but not the gender in the biological sense effect with the F score, which is the femininity score, decreases the probability of choosing the tournament. Okay. And if you add other controls, like these are the cooperativeness, dictator, investment, and in the Easy Potter and Binswanger task, we see that the only variable that matters is the Binswanger task. So people who take more risk, you are more risk-taking, are more likely to choose a tournament, which makes a lot of sense, of course. We observe the same thing. Have the effect of at least an accounting task, but if we add controls, okay, this effect disappears. And also it is nice to see for the counting task that cooperative people are less likely to select into tournament. And this is interesting to observe because it means that if you are cooperative, you don't want that other people actually lose. If you choose competition, you might make other people lose by choosing the tournament. If you choose piece rate, you avoid that. You keep your winnings for yourself. You don't share with anybody. Okay, but if you choose to enter in the tournament, you might expose other people to a loss, because if you are the winner, of course, you will destroy the other gains that all have chosen the tournament as well. And if you take both tasks, okay, both competitive tasks together, so this means this is the probability, the dependent variable is the probability to choose the tournament in both tasks together. Okay, so there are much less people, of course, who choose competitive tasks, but again, we have this variable athletes that comes out very clearly, cooperativeness and the risk attitude, the risk-taking in the lottery choice task that affects positively the probability. So that's the first result. The second result is that men and women to choose the tournament payment. Okay, so there is a gender gap. However, female athletes are equally likely than men non-athletes to select into competition. So again, we use logic regression and some Fisher test, exact test. So the first I show you so the test results. So here we have women and men, and the three tasks, the bold task, the count task, and both together. And you see clearly there is a gap between men and women. Okay, men choose much more frequently the tournament for the bold task. It's also true for the count task and for both tasks. However, the count task is not significant. This difference is too small to be significant. And maybe also there is a problem of power of comparison. It is interesting to decompose by gender. So here on this side, you have the woman, here you have the man, and you see obviously that this gender gap in competitiveness. First, you see that athletes are more likely, women athletes are more likely than women non-athletes to select into competition. Again, it's significant for the bold task, for both tasks together, but not for the count task. This difference is not significant. Same, you observe the same for the men. For men, men are more likely to select into competition compared to non-athletes. Okay, the difference is significant everywhere. Here it's only marginally significant for the count task. So the count task is actually the weak task, okay, which would have given quite weak results. What is interesting is to see the blues here. These are the women athletes compared to the men non-athletes, and you see clearly that women athletes are more likely to select into competition compared to men non-athletes. Okay, it's always larger. I don't have the test results here in these tables, but this is significantly larger than this one. And some are not significant, but this is good news. This would mean that women athletes behave equally to men non-athletes. So it's a positive result, because it means that there is no gender gap between these two categories. Okay, women athletes behave exactly with respect to competitiveness in the same way as men non-athletes. Finally, the third result is that it's about risk-taking. So this is less pronounced as competitiveness. Men take more risk than women. However, we have also a reduction in the gender gap when we compare female athletes and men non-athletes. So their risk are not different, which means that risk aversion is the same in athletes, female, than in men athletes, non-athletes. Sorry. Okay, maybe I don't need to go to all the support. So you see that in the Easy Potter task, for example, we have men invest 5.49 out of 10 compared to 4.28 for women. So this is significant. We have also tested the significance by using Tobit regression for the portfolio choice task, and for the lottery choice task, we use ordered logic regressions. So you see here for the investment task, okay, we have a gender effect, okay, not always, because if you control, for example, this is interesting to see that when you introduce the M score, masculinity score, the male effect goes away. And now we have a strong effect of the masculinity score, which is of the same magnitude, more or less, than the male score, the male effect. Okay, these are, again, it's a marginal effect measured in this. No, sorry, it's not. It's a Tobit estimate for this one. But you see, when you control for either for the M score or for the competitive index, you lose significance for the male dummy. Probably the choice of risk-taking is mediated by M score and also by CI. Okay. And when you actually put all together in a regression, you put all the variables, you have no longer any significance of the male dummy. This is for the Binswanger lottery choice task. Okay, so you have also male effect, okay, gender effect for this measure of risk aversion. But again, when you introduce the M score or the CI score, you lose significance of the male dummy as well as before. Okay. It seems that male dummy is a quite weak predictor of the of risk taking compared to other predictors. Finally, if you look at the stated preferences, stated risk preference, I don't know how much time I have. I'm almost finished with the results.
Yes,
We see there is a gap between male and female. I showed the gap between athletes and non-athletes. We have also a gap between male and female. Okay, in overall, sports, finance, and work. We have a gap, which means that male take more risk than female for these 3 domains and overall. Okay, now discussion. How can we explain our results? So we have actually summarized the results. The main results is that athletes are more likely to select into competition than non-athletes. Women shy away from competition in the bold tasks. This is very clear, but there is no difference in competitiveness between women athletes and men non-athletes. So the gender gap is actually closed between these 2 categories. Okay, and the same is true for risk taking. Women take less risk than men, so we have a gender gap in risk taking. But again, there is no difference in risk preferences between women athletes and men non-athletes. So the gap again is closed for these 2 categories. Several possible reasons of our results. We tested actually 4 of them. Athletes are better at the task. They are aware of that. They are better because they are more concentrated. Maybe they're used to train a lot, and so they believe they are better than other people. So that they get better scores. Okay, so we can test this very easily. Hypothesis 2 is that athletes are more risk-loving than non-athletes, and therefore they take the risk to enter in the tournament and eventually to lose the money. So because they like the risk, they are more likely to select into tournament. Very simply. The third reason is that athletes are less cooperative and more selfish. So they don't care, their other regarding preference is weak, and they don't care making other people lose when they choose a tournament. Because this is one of the reasons why you don't choose tournament. You don't want to make other people lose. And this is especially clear if you look at the women sample. They are much less likely to enter into the tournament, and are also more cooperative. So there is a correlation between these 2 dimensions. So maybe athletes are also entering because they are less cooperative and more selfish. And finally, athletes have a stronger taste for competition. I already talked about that. There are other reasons that we don't test that because we don't have the data for doing that. It could be that athletes are more overconfident. So they compete because they think, they believe they are more likely to win. They are more overconfident in their capacity to win the tournament. And also because they are looking for ranking feedback. They want to know their rank, okay? So if they choose piece rate, they cannot know their rank. If they choose competition, at least they know if they are first or second. At least they know that. So if they seek ranking feedback, they choose tournament. But we cannot test this because we don't have this data. So first hypothesis, athletes are better at the task. This is not true because if you look at this table, for example, you see here the performance, the scores by choice. Okay, you have for the ball task, for example, you have non-athletes and athletes, and you have those who choose the piece rate. So on average, they get 1.19 balls in the basket compared to athletes. So they are slightly better, but it's for piece rate. Those who choose tournament, you see that there is no difference. It's they are somehow better, but the gap is even wider for the non-athletes than for the athletes. Okay, so they have the same score. And if you look at the count task, you have also the same kind of difference. So actually, if you test that, there is no difference. There's no difference between in terms of score. So athletes do not perform better on average. It might never be the case that they might believe that they are better. But as I said, we cannot test this hypothesis. We can only look at the effective scores and not at the belief about the scores. Here you see also the scores. We have a regression. So that's just ordinary least square regression, where we take as a dependent variable the score. Here is the ball score, and the second part here is the count score. So column 1 to 3 is ball, column 4 to 6 is the count score. And you see the dummy variable athlete is not significant. So there is no significant impact of being athlete on the score. There is some impact of being a male, but you see that mostly there is no variable that explains the score. So it's It's completely, in some sense, random, the score. Second hypothesis is that athletes are more risk-loving, and that's why they select themselves more frequently into competition than non-athletes. Actually find it's true that individuals who are more risk-loving are likely to select competition, but there is only one risk-taking variable, which is a lottery choice that affects a tournament choice in both competitive tasks. And the general idea is that since we measure the marginal effect of this variable, BIN, which is the Binswanger measure of risk aversion, is very small compared to the athlete dummy. So the main driver of selecting into tournament is not risk taking; it is the athlete dummy that explains most of the variance. Here you have. This regression, which is
okay, Marc,
logic regression. Wait.
We should keep time for a discussion. So maybe.
Yeah. I try to finish. Okay. Basically, okay, we reject hypothesis 1, hypothesis 2. Hypothesis 3 is that athletes are less cooperative and more selfish. This is true, but this does not explain why they select more frequently into competition. For example, dictator giving has no effect on the likelihood to select into competition. Cooperativeness has some effect, a negative effect, as I showed, but again, it's a weak effect. Okay, so I don't show you the argument. Okay, I have an argument. And finally, hypothesis 4 is that athletes have a stronger taste for competition. Yes, you have two measures of that. Okay, selection into competition and CI, and both of them go in the same direction. So I just wrap up what I presented. I don't give you the details. So we have 3 statements. First, if you look at the behavioral trait that we elicited in this experiment, we have seen that athletes are more competitive according to CI, less cooperative according to prisoner's dilemma, more selfish in dictator game, have a higher M score, and state higher propensity to take risk in general and in sports. We also observe that athletes select into competition more frequently than non-athletes. And finally, women athletes do not differ from men non-athletes with respect to selection into competition and risk preferences. So again, the gender gap between these two categories, women athletes and men non-athletes, shows that this gender gap is much more smaller than the usual gender gap. So sport practice seems to be a way to close the gender gap. And I thank you. And again, I wish you a happy new year and good health for the coming year.